probability and experimental probability. What we're going to look at is applying some geometric pieces to probability and finding the probability of an object hitting basically a target in a sense. So the probability, basically putting in with area, it's going to be the probability of that specific, that desired or specific outcome that you're looking for, that area divided by the total area. So we're going to have to go back to last unit and remember our area formulas. Remember that probability is still calculating the likelihood of an event occurring. And this is going to be without actually performing the experiment. So that if we were actually throwing darts at a target or anything like that, that's the probability. That would be the probability of an area and actually recording those. And then that would be our experimental. But we're just going to look at theoretical here. All right, so first example, this one is a little bit involved, but we're going to work through it. So a dart is thrown at random. So it has to be randomly because if you're trying to shoot for something, that changes the probability. And the diameter of this target here of the blue is 10 inches, the diameter of the yellow is 6 inches, and the diameter of the red is 2 inches. And we're going to find the probability of hitting a red, a yellow, and then not a blue. So what we'll do here, we're going to find the probability of hitting the red. So that's the probability of a red divided by, or excuse me, the area of the red divided by the total area. Well, let's first find our total area because that's going to be our denominator for every time. So our total area is going to be pi times. Now we're finding the area. So the whole thing is that area basically with the blue. So it's going to be pi times 5 squared because the diameter is 10, so the radius is 5. So that gives me 78.54. So we'll need that every time. And then we're going to find the area of the red. Well, the area of the red is going to be pi times 1 squared since the diameter is 2 inches for the red there. Then I'll divide that by my 78.54. This, when I multiply pi times 1 squared, that gives me just 3.14. It's just pi divided by 78.54. And then this is going to be, I'm just going to write this as a decimal, so 0.04 or a percent, which would be 4%. So before, when we had drawing a marble out or whatever, it was easy to look at the fractions that way. This, not so much because there's so many decimals here. Now we're going to find the probability of a yellow. So I need to find the area of a yellow. Well, the area of the yellow is going to be the area of this outer piece minus the red because the red does not count as yellow, obviously. So the area of the yellow is going to be pi times the radius, which is 3 squared, minus the area of the red, which we found to be 1.3, or excuse me, 3.14, divided by our total area, which is 78.54. Then I will just take that numerator, find out that it is 25.13 divided by 70 or 78.54, which is going to give you 0.32 or 32%. And then the last one, not blue. So this one is pretty involved. This is the one where you'll want to use the fact that you have 1 minus the probability of a blue. So let's take that and run with it. So I have 1 minus, I'm going to do P blue. So this is going to be 1 minus the probability of a blue. This one is basically just as involved as the yellow one because if I just take away the yellow square, the red square is with the yellow square. So I can find the area of the blue, which is pi times 5 squared, minus the area of the yellow, which is pi times 3 squared, and then divide that by our 78.54. Once you divide those two, and then you'll do 1 minus that. Excuse me, this is going to be 1 minus, and this is 50.27 divided by 78.54. So I did this all in one step. I just divided this. I put this in parentheses, and then I did 1 minus that, and you get 0.36 or 36%. So really the likelihoods of hitting yellow and not blue is obviously pretty close together, or about the same. What you'll notice is that the probability of not blue is the probability of red plus the probability of yellow. That makes sense because it's those two, because those two are not the blue. So that's how that works there. I'm going to erase this so I have room to work over here. All right, so the rest of them are not as involved just because of all the pies and all that good stuff. So we're going to find the probability that a ball thrown at the target will hit the shaded region. So the probability of hitting the shaded region is going to be the area of that shaded region, area of the shaded, divided by the total area. So we'll need to find the total area. So the total area is going to be this rectangle here, which is an 8 by 6. So total area is going to be 8 times 6, which is 48. Now then, the area of that shaded region, you're going to have to subtract the circle from the outer piece. Also note that this radius here is half of the diameter, which is that height there. So the radius here is going to be 3. So the area of the shaded region is going to be 48 minus pi times 3 squared, and then divided by 48. And then I do this all in the calculator at one time, and I get 0.41 or 41%. So almost 50-50 chance. That seems kind of odd, but that's because it's thrown randomly. You're not trying to hit the center target. So if you kind of take the other piece and scooch it down, looks about like 40%. Okay, let's look at example 3 here. What's the probability of hitting one of the targets? So this time, I'm not trying to figure out, I'm not trying to take out anything. I'm trying to find basically the area of those shaded regions divided by the total area. So let's look at that first, that total area. So the total area is going to be that it's a square essentially. It's 13 times 13, and that gives you 169. So the probability of hitting a triangle, I'm just going to use a little triangle sign there, is going, you have two of them, I have two triangles, times the area of a triangle, which is 1/2, times base, which is 3.5, times the height, which is 5 here. And that's all going to be divided by 169. So what I get here is I just did this all together, and I get 0.10 or 10%. Now these are rounded to the nearest hundredth. So this is 2 decimal places. Remember, getting the percent, you just move the decimal over 2 places. And that's it. Find the area. So the likelihood of hitting the triangle at random. So again, it's not like I'm trying to hit the triangle. It's just like I'm just randomly, I got blindfold on or something. I'm just randomly hitting that. So that's kind of an important piece there. Okay, the probability of a spinner, you're going to find the probability of a spinner landing on green. Now, there's one slight thing you need to add here, and we'll have to add the radius. So the radius here we're going to say is 5 inches. Now, we're going to find the probability of the spinner landing on green. So I need to find the area of green first, divided by the total area. So the total area for this spinner is pi times 5 squared. Well, guess what? We did that in problem number 1. So that's 78.54. So the probability of green is going to be the area of a sector. So that's that the little piece. That's why you need this degree sign there. So I have 170 divided by 360 times pi times r squared, all divided by 78.54. So once I take the numerator, plug it into my calculator. Oh, I'm not going to use r. I'm going to use 5 here. Make this a 5. And so I plugged all that numerator into my calculator. I get 37.09 divided by 78.54. And that is going to give me 47%. Well, we'll say it's 0.47 or 47%, which makes about right because 170 and we have 180 would be half of the circle. That'd be 50%. Now let's look at the probability of not landing on the yellow. So probability of not yellow. Now what you'll notice is that the yellow is 1/4. And how do I know it's a fourth? Because it's a 90 degrees. So 90, 180, 270, and then 360, all 90 degrees. So this is a 1/4. The rest of these two sectors added together would be that'd be 3/4. So the probability of not landing on yellow would be 3/4 or about 0.75, 75%. So on this one, because it's a nice pretty 90, it's a little bit easier. You could add the two sectors together, like 70 plus 100, that give you 270, and then follow the same process. But you can also use the fact that you know that 90 is a fourth of the circle, and then so therefore the probability of it not landing on that would be 3/4. Remember, because not is 1 minus the probability of yellow. All right, so a lot going on here. It's a lot of calculation, and having to refer back and finding the area of specific pieces. I would say main thing is going to be the area. I mean, rectangles and triangles, and also circles. I think that those will be the main three that you need to make sure that you know the area formulas for to help you out. So now it is going to be your turn to practice with your skill check.